Good morning, everyone. Today's my talk is about using air quality modeling to study various control strategy in China. And the title of my talk is on air quality and health co-benefits upon China's integrated air control policy during 2015 and 2019. So the area of study is southern China, we call the Pearl River Delta, in short PRD. And the pollutant we are looking at is PM2.5, NO2, and ozone. And after we study the concentration, we look at all these reductions, what is the health benefit of that. So the research framework is we're using a very standard, we call air quality model, consists of three parts. The first one is called the emission model. The one we use is called the smoke. And then we're using a meteorological model we call WRF. Basically, we're doing hour and hour simulation of the full field. And of course, we compare that with the observation data, make sure we have a reliable meteorological field to drive the air quality model CMAQ. And once the pollutant released into the atmosphere together with the meteorological model, we can find out various chemical reaction in the atmosphere by this photochemical model. So the domain of study, which is demonstrated in these two graphs. So we have four domains, from the largest domain covering the whole China with 27 kilometer resolutions. Slowly we're zooming down from 27 to 9 to 3, and then eventually down to the finest resolution, 1 kilometer resolution into this PRD domain. So the blue is the meteorological model, and then the red is the photochemical model CMAQ. And in terms of the emission inventory, we're using two approaches. The first one is we call the bottom up for the two finest domain for the Hong Kong and PRD. And then the emission inventory, we get very detailed emission inventory working with the Hong Kong government. For example, like the traffic data, we have all the activity data so that we can know each vehicle type, the year of the vehicle, to estimate the emission of the mobile sources. So it's very detailed indeed. And for the PRD, we work with Professor Alan Zhang to obtain the PRD emission inventory. For the bigger domain, D1 and D2 is a coarse resolution. So we obtain the data set from the Tsinghua MICS data in 2012, and then we project into 2015. The biogenic emission, we're using the Megan model. So basically we have, of course, the first thing we do is we do a base year, 2015, establish the credibility of the model first. We do all the validation together with the meteorological field as well as the air quality model. And then afterwards, we study four scenarios. The first one is from 2015 to 2020. Study the control measure of the 13th five-year plan as well as the Hong Kong government with control strategy, and try to project from 2015 to 2020 what is the air quality reductions. And then afterwards, we taking progressive control measure, more aggressive. So second one is assume if the Guangdong government electrifies all the public buses as well as all the car become Euro 6 standard, and all the coal power plant using LPG. And then further on the scenario 3, we assume all the industry and area source become more efficient, so their emission is become half of the current situation. And lastly, and of course, the control strategy is not only in PRD. We are hoping in the whole China, they are also adopt a similar aggressive control strategy, and all the buses electrifies, car become Euro 6 standard, and all the industry have half the reduction. And then we want to study what is the impact on the PRD, their emission, their concentration. So first, let us look at the PM2.5 concentration. Okay, so this is the annual average of PM2.5 concentration. So the color represent the concentration. the cold color is low concentration, the hot color is a high concentration. So as you can see, this is the current 2015 situation. The hotter the color is the higher the concentration. As you can see, progressively, if we are taking very different control strategies, scenario 1, scenario 2, scenario 3, and scenario 4. So the red area become smaller and smaller, diminishes. The bluer the area increase. If we're taking the last measure, you can see the whole PRD region become the concentration, most of the part is less than 25 microgram per cubic meter. Now, if you actually look at the container map and attainment map, it's a little bit easier to understand. Okay, this is the WHO standard on a very different color. So the yellow color is IT1, light blue color is IT2, dark blue color is IT3, and then if green is the ultimate AQG standard. So as you can see, for 2015, we have quite a lot of red area as we take different control measure, and then eventually you can see if we take the most aggressive control measure, the old PRD would have obtained IT2 standard, and Hong Kong actually reaching IT3 standard. It's not quite the AQG yet, but it's IT3 standard is very good already. So if we're taking all these control measures. Okay, now if we look at percentage changes in very different regions due to various control scenario, this gives you an idea what is the concentration changes. Originally, like for Hong Kong, originally the annual average, if you do the domain average, about 22, and eventually become around 12. And this is the corresponding percentage changes. So the percentage can have reduction close to about 45%. And similarly for the PRD, if we do the domain average, you can see the reduction is even more, close to about 50% reduction. Now, the beauty about the air quality model is not only we can looking at the Hong Kong and PRD as well as individual counties. If you are actually interested on individual counties, very different measure, and what is the concentration changes as well as the percentage changes, we can also doing study on this one using the air quality model. Okay, the other one we would like to look at, of course, with all these concentration reduction, what is the health benefit of that? So the way we're looking at that is we're using so-called the added risk parameter to quantify the health benefit of that. So typically, this is the added risk well-known formula. So this is tell you the added risk of due to the ozone concentration. The beta value is typically is a parameter which is reduced by the hospital admission. So similarly for the NO2, so we're using a similar formula to calculate the added risk. And the co-benefit of that is just the linear combination of that. Okay, now this is the NO2 concentration map. This is not exactly is the concentration map. This is the difference on various control strategy. And this is the, yet again, is in microgram per cubic meter. The hot color, it tell you is the increase. The blue color tell you is the decrease. Whenever we have blue, that means the control strategy is effective because it's a reduction in concentration. So this one is the scenario 1 minus the control. So if there's a blue color, that means if we are taking the control measure from 2020 to 2015, you see there's a large reduction in concentration in NO2. And then if we do the control measure in power plant and traffic, you see there's yet again, there's a large reduction in concentration of NO2 in the rest of the PRD. Now, if we do the industry and area source, not as effective, but you see a little bit spotty because this is where the industrial area are. And finally, if we do the control measure for the rest of the China, because NO2 is a local sources, you can see the benefit is not that large for the pollutant of NO2. But however, if you look at ozone, okay, now ozone, which is what happened if you look at it in the control measure, because most of the control measure from 2015 to 2020 is in the NO2 pollutants. So in fact, you can see with this control measure, the ozone is actually have a little bit increase over Hong Kong and the Shenzhen area because of the less NO2 in the atmosphere, less trization. So as a result of that, you actually lead to an increase in ozone concentration, which is what we have been observed for the last few years in this part of China. Now, if you do another measure, if you look at the difference and you see there's some reduction, this blue spot is mainly related to the power plant, because when we have reduction, when we change the buses to electrical bus, there's a bigger demand in electricity, so that we produce more, have a little bit more NOx, so the ozone actually have been reduced. So if you look industry, some of them increase, some of them decrease. But however, if we do the control measure for the whole China, working with the other national government, you see the whole domain become negative. The reduction is about 10 microgram per cubic meter. Now finally, I want to look at this is the ultimate thing we want to look at. So with the reduction of the NO2, with a little bit increase in ozone, so what is when you add these two together, whether we have health benefits? Okay, so this is the percentage difference of the added risk. Okay, yet again, this is the percentage. The blue color is the reduction, the hot color is the increase. So if you look at, this is the cumulative added risk. Okay, so let me look starting from this one. From 2020 to from 2015 to 2020, you see there's a little bit blue here. That means although there's a reduction in NO2, increase in ozone, but overall the health benefit is still negative. If we do more control measure on power and traffic, the color become bluer. That means the added risk is become more negative, which is better. So if we do more control on industry and area, become even more bluer for the remaining part of the PRD. If we do the whole China, you can see the whole PRD benefit a lot, becomes so blue. Okay, the added risk reduced by about 1.5%. So demonstrated, okay, despite there's a little bit increase in ozone with the NO2 control, but the co-benefit of the health impact is actually quite positive. So the conclusion of that is, through this study, I demonstrated the usefulness of the air quality model, and you can study where is the control strategy. And then I have demonstrated with this control measure from 2015 to 2020, the control measure is actually quite effective. The Hong Kong actually reached the IT2 standard. With more aggressive measure of the PRD, okay, with industry and then buses, mobile control, actually the whole PRD can reach IT1 standard, i.e. less than 35 microgram per cubic meter, the annual average. And then finally, if we work with the national government, okay, I actually demonstrated the PM2.5 actually for the PRD can reach IT2 standard, Hong Kong can reach IT3 standard. So that's demonstrated the importance, actually not only working with the local government as well as the national government. Finally, when we study the co-benefit of the short-term health impact of the NO2 and then the ozone, I demonstrated the health benefit is quite positive, and also demonstrated this region is VOC limited. So the next important control measure is actually on VOC, which in this conference actually there's quite a lot of speakers actually talk about control measure on VOC. With that, thank you very much for your attention. If you have any question related to this talk, you can certainly welcome to email me. Okay, thank you very much.